Hi everyone, welcome back to lab. In this video, I'm going to go over some basics about IntLists and also what the term destructive versus non-destructive means. Okay, so as the lecturer kind of mentioned, IntLists in 61B essentially is similar to linked lists, which you might have seen in 61A or other CS classes at Berkeley. It is essentially an implementation of linked list that only stores integer. So if we draw it out, the int list looks like the following. It has a head and a tail for every single element in the int list. And the head essentially stores an integer, for example, 1, and then the tail stores a reference to the next element in the int list. So here we represent it as a pointer that points to the next element in the int list. And we can keep drawing this and so on and so forth. So this is essentially how you can visualize an int list. And this is the kind of the implementation we have for it in this lab. And when writing code, there are multiple ways where you can construct an int list. The most, I guess, naive way is to use the new keyword as, new int list to instantiate an instance of the int list and just keep wrapping it and keep extending it by pointing the tail to a new instance of the int list element. So I'm not going to keep writing this, but you can find kind of this one method of instantiating an int list in the last spec. We can keep going. However, this can be really tedious if you want to quickly construct a very long int list. And in the lab, there's an implementation for you to quickly construct an int list that's really long using just one line. So the other way, where I will highly recommend you guys to think about it using this way when you're implementing the code for this lab, is by using the intlist.list method. So intlist my list equal to intlist.list. So for example, if I want to construct an int list with 4 elements, 1, 2, 3, 4, I will just call intlist.list and pass in the 1, 2, 3, 4 into this into the list method. Okay, so this you can pass however many numbers you want the int list to have. Okay, cool. So now knowing the basics of int list, I want to talk about this term destructive versus non-destructive. Okay, so destructive essentially kind of by what the word says, it means that the object that you're working with has been destroyed or changed somehow when you're executing the code. So in this case, let's say we have this list A, or I always call it my list. Let's say we have this int list A. In whatever method you're looking at, we say the method is destructive if we somehow change the content of the object, which is an int list in this case. So if this is changed to 100, 200, 300 after we execute that piece of method, then we say that that method is destructive. In another, in contrast, non-destructive basically means that the object was not changed at all. It stays as it is when we pass in to the method. After the method finished executing, the int list didn't change at all. So that means that non-destructive is still stayed at 1, still stayed at 2, still stayed at 3. Then that means that the method is non-destructive. Okay, so hopefully this clarifies the term non-destructive versus non-destructive. And I would recommend you all to look at the code, the skeleton code in intlist.java in lab 2 to figure out, which method is destructive, which method is non-destructive. having an understanding of the skeleton code, your task for this lab is to fill out the test square list recursive method in the IntList test.java file, and then try to test the non-destructiveness and what the correctness of the square list recursive method. So I recommend you all to first look at the skeleton code to understand it, and then complete the test. And then you can submit the lab to the auto grader to see if you got all the tests passed. Okay, so hopefully this quick overview of IntLists was helpful. Thank you guys for watching, and good luck writing the code for IntLists. Okay.